We're here at Mcity, part of the University of Michigan's Mobility Transformation Center, also known as MTC. This is the only facility of its type in the world. It is a safe, controlled environment in which to test connected and automated vehicle technologies. This is not what you would normally think of as an automotive test track, because it's not about endurance or durability. It's not high speed. It's about dealing with the complex real-world scenarios that autonomous and automated vehicles are going to have to contend with. It's built to real-world standards, has all the attributes that vehicles will encounter in the real world. We need a closed, secure, safe, repeatable environment, and that's what Mcity provides. All of these attributes that we've included all present different types of challenges in terms of recognition or potentially even blocking vision or wireless communication signals. These are things that are in the real world and that real world automated vehicles are going to have to learn to contend with. We are not going to rebuild all of our infrastructure in order to accommodate automated or autonomous vehicles. Vehicles are going to have to learn to operate in the legacy system that we have. So some of the specific attributes that we have include the stretch of road that we're on right now. It's a gravel road. Fully autonomous vehicles are going to have to be able to operate on a wide range of roads and under different road conditions. So this road doesn't include any lane markers. It does not a nice smooth surface. It's kind of wandering and meandering. So the higher speed section, the straightaway, actually has exit and entrance ramps, two different styles, one urban, one suburban design. And that allows us to test the way vehicles will exit and enter the flow of traffic on a higher speed road. Also as they merge into and out of platoons, long strings of vehicles. There's 2 lanes of concrete, 2 lanes of asphalt. There aren't any permanent lane markings, and that allows us to change things like the lane width, whether it's 12 feet or 8 feet. This is also perfectly oriented north-south. That allows us to test the accuracy of global positioning systems. We already have a number of locations with pedestrian crossings, both mid-block and at intersections. You'll notice that our signs are not all pristine, and that's done very intentionally. We want to have signs that represent real-world challenges for image processing systems to detect. Most of the intersections that we have here on site will actually have traffic signals, traffic lights. We have a boulevarded roadway that is perfectly oriented east-west for GPS accuracy testing. We have parking spots, parking meters, parallel parking, diagonal parking, and stall parking like you might find in a parking lot. We have a downtown area here with these building facades using real-world building materials, including glass, brick, wood, aluminum, vinyl, because different sensing technologies that the manufacturers use will reflect off of these surfaces differently and produce different results. We have a simulated underpass / tunnel. This allows us to test the effects of blocking wireless signals like global positioning system signals, as well as wireless vehicle-to-vehicle communication. We have an active railroad grade crossing, so there's gates and lights and real rail track installed. We have a simulated tree canopy where we'll test the effects of blockage of wireless and GPS signals that you would find on a suburban street with large older trees, branches covering the roadway. We have 4-way stops. We have lighting throughout the facility with different types of lighting sources. We have these decent size flat asphalted areas. This will allow us to design and configure intersections and parking areas that we don't otherwise have represented in concrete and asphalt already. We have real-world attributes such as mailboxes, fire hydrants, park benches, parking meters, everything that an autonomous or automated vehicle is going to have to contend with in the real world. We have obviously a mix of concrete and asphalt. We also have some concrete that is stamped like a brick road. This is an investment on the part of the university and the state of Michigan, Michigan Department of Transportation. It did not use corporate funds, although we have many corporate sponsors in the Mobility Transformation Center. But this facility was deemed to be so necessary that the university and the state were willing to invest in its construction. This type of testing is critical in order to ensure that the future automated and autonomous vehicles and connected vehicle technology work effectively and safely out on the public roadways.